Beneath the red deserts of central Utah lies a mystery frozen in stone. A pit filled with more than 10,000 bones tangled, fractured, and twisted together like a prehistoric crime scene. For over a century, scientists have called it the Cleveland-Lloyd Quarry, but a better name might be the death trap. Here, predators outnumber prey. 3/4 of the fossils belong to one creature, Allosaurus fragilis, the Jurassic apex hunter. Dozens of them, from hatchlings to full-grown killers, piled in a single layer of mudstone. It's as if a pack of lions had all died in the same watering hole. The desert wind whispers across the cliffs. Bones glint beneath the sunlight. And still, one question refuses to die. What killed them all here? The story began in 1927. A rancher near Price, Utah, noticed fragments of bone weathering out of the desert floor. He called in paleontologists from the University of Utah, and soon a team led by William Stokes began to dig. What they found stunned the scientific world. Not a skeleton, but a chaos of skeletons. Thousands of bones crushed and scattered, many belonging to Allosaurus, Stegosaurus, and Camarasaurus. Some were beautifully preserved, others shattered into powder. The layers showed no volcanic ash, no flood debris, no asteroid fallout, just endless mud. Then, for decades, the site went silent. The Great Depression halted funding, and the quarry sat buried under sand once again. In 1960, it was rediscovered, this time under the direction of James Madsen, who would spend his life untangling the puzzle. He unearthed over 46 individual allosaurs, the largest single concentration of carnivorous dinosaurs ever found. But even after 50 years of study, one truth remained: the bones made no sense. To walk through the quarry today is to step into organized chaos. Skeletons are incomplete, crisscrossed, and missing crucial parts. Skulls face backward, ribs jut upward like broken sails. Some bones show bite marks, others deep scratches from claws. It's not a calm burial ground, it's a battlefield. But there's no sign of catastrophe, no tsunami, no volcanic ash. Instead, scientists find a slow accumulation layer upon layer of death. One theory says the quarry was once a shallow sinkhole, a muddy depression filled with water during wet seasons. Animals came to drink and slipped into the mire, unable to escape. Predators came after them, and they too became trapped. Over centuries, the pit became a deadly magnet, claiming life after life. Still, something about the pattern feels wrong. Why so many predators and so few herbivores? Why were the bones chewed often by the same species? The Cleveland-Lloyd site wasn't just a trap. It was a predator's graveyard. The Allosaurus was no ordinary predator. At 30 feet long and weighing 2 tons, it ruled the late Jurassic landscape. Its skull was light but deadly, its jaws lined with 60 serrated teeth. But at Cleveland-Lloyd, its dominance became its downfall. Most of the fossils showed trauma-crushed skulls, broken legs, shattered vertebrae. Some even show healing, suggesting violent lives before death. And scattered among adults are the bones of juveniles, dozens of them. Why would so many young predators die here? Were they born nearby, drawn to a nesting site, or were they hunting together and failing together? Some scientists propose that Allosaurus hunted cooperatively, like wolves or lions. If a herd of Camarasaurus became stuck, multiple predators might have converged a feeding frenzy that turned fatal. Others think the quarry was a trap that lured in scavengers one by one. The first allosaur died in the mud. The next came to feed and joined it in death. Predator by predator, the pit filled itself. This became known as the predator trap theory, and for decades, it defined the Cleveland-Lloyd narrative. It explained why predators outnumbered prey 10 to 1. Each allosaur drawn by the scent of decay, each trapped by the same mud over thousands of years. The pit became a self-feeding ecosystem of death. But not everyone agreed. The sediments tell a subtler story. Microscopic layering suggests periodic drying and refilling, not a permanent lake, but a seasonal trap. Perhaps the Allosaurs weren't lured by meat, but by thirst. A drought could have driven entire populations to the same shrinking pond, desperate for water. When the mud hardened, it caught them in place, their bones later swept into a single basin. This new idea would come to be known as the drought hypothesis, and it reshaped how paleontologists viewed ancient death traps. Imagine the Morrison Basin 155 million years ago, a semi-arid plain dotted with oases and marshes. Rain came rarely, but when it did, it flooded the land. During long, dry spells, the lakes evaporated, leaving behind shallow pools thick with clay. Animals gathered at these last water sources, Stegosaurus dragging their plates, Camarasaurus wading in up to their knees, and wading nearby, the Allosaurs. They struck when prey grew weak, but as the pond receded, the mud thickened. One by one, the predators too became trapped. Their roars turned to silence, and when the rains finally returned, the pit filled again, sealing their remains in mud and memory. Isotopic analysis of the sediment supports this oxygen levels fluctuate between wet and dry seasons, matching drought cycles. Still, the bones tell a darker side of the story. Many were gnawed, not by other species, but by fellow Allosaurs. The quarry was no longer just a place of death. It was a place of hunger, desperation, and cannibalism. When scientists examined bite marks under magnification, they discovered something unsettling. The spacing of teeth matched perfectly with Allosaurus jaws. On one femur, an Allosaur had bitten another of its own kind clean through the bone. Whether it was scavenging or true cannibalism, no one knows, but it fits the story of a drying world predators turning on each other when prey vanished. Paleontologist James Madsen once wrote, "Cleveland-Lloyd is a monument not to life, but to hunger. It's a scene of survival, stripped bare ancient carnivores, locked in an endless spiral of need." To walk through the quarry is to feel that tension, the thin line between predator and prey erased by time. Even today, bones from new excavations show layers of bite marks, stacked like signatures, proof that death came not once, but in waves. Still, some researchers argue for another possibility, that death came not from hunger or thirst, but from poison. The Toxic Mire hypothesis suggests that decaying plant matter in the stagnant pool released deadly gases, hydrogen sulfide, methane, carbon dioxide. Animals entering the depression would be overcome within minutes, suffocating before they could escape. Modern analogs exist in East Africa, where herds of antelope collapse at the edges of volcanic lakes filled with invisible gas. Their bodies pile up in eerily similar patterns, predators among prey. Faces turned downward, lungs filled with silence. If true, Cleveland-Lloyd wasn't just a trap. It was a prehistoric gas chamber, nature's own killing ground. Chemical traces of sulfur in the sediment lend support. But the debate rages on. Each new analysis adds another twist to the story and another ghost to the pit. Today, technology has turned Cleveland-Lloyd into a living laboratory. High-resolution 3D scans map the position of every bone in virtual space. Geologists analyze isotope ratios to track ancient climate shifts. Paleontologists simulate water flow through digital terrain models, watching how carcasses might drift and settle. Artificial intelligence compares tooth marks to 3D printed replicas of Allosaur jaws, confirming predator identities. Even the coloration of the soil reveals oxidation patterns, silent fingerprints of prehistoric decay. The conclusion: the quarry wasn't formed by one catastrophe, but by centuries of smaller tragedies, droughts, hunts, poisons, and chance. Life and death, repeated over and over until the pit overflowed with memory. Every bone is a data point, a timestamp, a witness. Together they tell a story that's less about extinction and more about persistence, how ecosystems recycle death into life. The death trap wasn't just the end of dinosaurs, it was their echo chamber, the earth recording every scream, every silence, every breath of their final days. Today, the Cleveland-Lloyd Quarry is quiet again. Wind cuts through the canyons, and dust drifts across the fossil beds. Visitors walk along raised paths, looking down at bones that once tore through flesh and time. Each skull tells a story: the hunter that slipped, the scavenger that starved, the survivor that didn't. Their bones lie side by side, predator and prey, youth and age bound by the same fate. The quarry still holds secrets. New layers are being uncovered, and chemical fingerprints may yet reveal the true cause of death. But maybe that mystery is what keeps it alive in our imagination. We've searched for monsters in stories, in fossils, in our own reflection. And Cleveland-Lloyd reminds us sometimes the monster is simply life itself, too hungry to stop. As the sun sets over the Utah desert, the red rocks burn with ancient light, and somewhere beneath them, the ghosts of the Jurassic still wait, jaws open, eyes empty, frozen forever in the world's oldest trap. They were hunters once. Now they are the hunted by time, by curiosity, by us. The desert keeps their secret, and science keeps asking, what really happened here?